Switches are the communication experts in our networks. They intelligently route data to its destination across all communication levels, from OT, operational technology, and IIT, industrial IT, to IT. How do they function and what do they actually achieve? Let's take a look at the OT level in the Profibus fieldbus system. High-performance infrastructure components like switches are not required yet in this context, because master and slaves only communicate sequentially according to the question-answer principle. Compared to road traffic, this would mean that only one vehicle can drive in one direction at a time between the production plant and the supplier. In Ethernet-based systems such as PROFINET, there is a two-way lane. Telegrams not only run between the controller and devices, or in IT between the server and clients, but devices also communicate with each other, bypassing the controller. Switches are as important to these systems as traffic lights are in road traffic. The modern switch is comparable to a logistics hub. Just like packages on a loading dock, telegrams are received and sent via so-called ports. With an 8-port switch, 8 different data connections to devices or other switches can be created. Each port runs either in gigabit, 100 megabit or 10 megabit speed mode. This depends both on the type of data cable, for example whether it is a highway or a rural road, and on the quality of the cable. A vehicle, for instance, would have to drive slower on a road with potholes. These two factors also affect the transmission mode of a port. If the faster, so-called full duplex mode is used, telegrams can be sent and received simultaneously. However, if there are problems on one of the data lines, the affected port automatically switches to half-duplex mode, which supports parallel only, send or receive. Doing so delays the data processing enormously. Once the data line is fully functional, the system automatically switches back to the fastest possible transmission modes. This is called auto-negotiation. An important consideration for a switch is its memory. It is used for incoming and outgoing frame queues, the so-called input and output queues, as well as for interim memory, also known as buffer. Let's join a telegram on its way through this memory and through the switch. First, an incoming telegram reaches the input queue. In store and forward mode, it is checked for errors in the checksum and deleted if necessary. Immediately, the MAC address is used to read out to which port it is to be routed. It now enters the buffer, where it is sorted and temporarily stored. Finally, it is relocated again according to the first-in, first-out procedure and forwarded to the corresponding output queue. Switches often operate in store and forward mode. However, there are also cut-through switches that move telegrams directly from the input queue to the output queue without checking for errors. This shortens the processing time but increases the probability that faulty telegrams will be forwarded. However, a cut-through switch will automatically switch to store and forward mode if the load on the output queue increases significantly to avoid data loss. With TSN, lead times are minimized and a return to store and forward mode is no longer necessary because capacities are reserved in the queues. In dynamic mode, the memory of an underutilized output queue is simply used at another output queue for sending telegrams. Modern switches have a prioritization mechanism. This means that time-critical packages, such as PROFINET telegrams in OT or Voice over IP in IT, can always be given priority in the network. Acyclic large data packages, which place a heavy load on the lines for a long time, have to wait. A good switch has several output queues per port and significantly more memory space. Each switch counts the incoming and outgoing telegrams, but only a good switch automatically calculates the net load in percent and shows peak loads in the millisecond range. Switches can withstand high net loads. This power is represented in PROFINET by the so-called net load class, where level 3 is the highest. In IIT and IT, the performance of a switch is defined by the switching capacity, how fast it can store and retrieve, the switching memory, how much memory space it has, and the switching speed, how fast it works. Frequently, telegrams from several input queues are almost exclusively routed to one port, for example to the backbone or the controller. This results in its output queue becoming full and all new incoming telegrams being lost. These so-called discards are a sure sign of unstable network communication. In mechanical engineering and plant manufacturing, unwanted leakage currents often occur on the data line shielding, comparable to a thunderstorm. They are a strain on telegram traffic. A good switch can withstand these EMC influences, monitor them, and report rising loads. A managed switch is essential if all these operating parameters are not only to be recorded, but also made available externally for analysis. This is the only way to eliminate critical network conditions in a timely manner before a breakdown occurs. A good switch has SNMP access, a web interface, and onboard network diagnostics. Thanks to the remote access, this data also forms the basis for diagnosis and maintenance over long distances. Switches should have a so-called mirror port if a telegram analysis is necessary. It mirrors the telegrams of a port as a one-to-one copy to another free port. A good managed switch always delivers the necessary data for network monitoring and an up-to-date topology plan to the management software intended for this purpose. The safe way into the future is therefore through a high-performance managed switch that makes your maintenance plannable and your plant operations stable in the long term. The switches of the ProMesh series from indu-sol make exactly that possible. Now it's up to you. An intelligent switch choice determines whether you have the upper hand over your network or your network has the upper hand over you.